expression. Write your answer as a power. First, let's review the product of powers property. This property says that to multiply powers with the same base, add their exponents. Notice that in each of these examples, with numbers and variables, the base is the same, and the powers are multiplied. Based on this property, when these two requirements are satisfied, we can add the exponents. Let's look at an example. Simplify the expression 6 squared times 6 to the 7th. Note that the powers have the same base, 6, so we can use the product of powers property. Keep the base, 6, and add the exponents, 2 and 7. 2 plus 7 is 9, so the expression can be simplified to 6 to the 9th. Let's look at another example. Simplify the expression -2 times -2 to the 3rd. Remember that a number written without an exponent is the same as that number raised to the first power. Notice that the powers have the same base, -2, and are multiplied. This means that we can use the product of powers property. Keep the base, -2. Don't forget to include the parentheses to show that the negative sign goes with the 2. Next, add the exponents, 1 and 3. 1 plus 3 is 4, so the expression can be simplified to -2 to the 4th. Let's look at one more example. Simplify the expression x squared times x to the 5th. Notice that the base is a variable, x. The bases are the same, and the powers are multiplied, so we can use the product of powers property. Keep the base, x, and add the exponents, 2 and 5. 2 plus 5 is 7, so the expression can be simplified to x to the 7th. Simplify the expression. Write your answer as a power. The expression is the quantity 5 squared raised to the 3rd. To simplify the expression, we want to use the product of powers property, but we do not have powers that are multiplied. Remember that a power is a product of repeated factors, and the exponent indicates the number of times the base is used as a factor. So we have an exponent of 3 and a base of 5 squared. This tells us that 5 squared is used as a factor 3 times. So let's rewrite the expression using repeated multiplication. We have 5 squared times 5 squared times 5 squared. Now we have the same base and powers that are multiplied, so we can use the product of powers property to simplify. Keep the base, 5, and add the exponents, 2 plus 2 plus 2. The sum of the exponents is 6, so the expression can be simplified to 5 to the 6th. Let's look at another example. Simplify the expression, the quantity y to the 4th raised to the 6th. Once again, we do not have powers that are multiplied. We have an exponent of 6 and a base of y to the fourth. So we can use repeated multiplication to rewrite the expression. The base, y to the fourth, will be multiplied 6 times. Now we have the same base, y, and powers that are multiplied. So we can use the product of powers property to simplify. Keep the base, y, and add the exponents. We will add 4 6 times because there are 6 factors. The sum of the exponents is 24. So the expression can be simplified to y to the 24th. Simplify. Simplify the expression. The expression is the quantity 4x squared. What does the exponent of 2 tell us to do in the expression? It tells us to use 4x as a factor 2 times. Rewrite the expression as repeated multiplication, 4x times 4x. This can also be written as 4 times x times 4 times x. Now use the commutative property of multiplication to rearrange the terms, so that we have 4 times 4 times x times x. Then use the associative property of multiplication to group the like terms. Next, we can use the product of powers property to add the exponents. We have the base 4 with the exponents 1 and 1. And we have the base x with exponents 1 and 1. When we add the exponents, we get 4 squared times x squared. Finally, we need to evaluate 4 squared. 4 squared is 16. And keep the x squared because this cannot be evaluated. So, the simplified expression is 16x squared. Let's look at another example. The expression is the quantity w times z cubed. The exponent of 3 tells us to use w times z as a factor 3 times. So rewrite the expression as repeated multiplication. We have wz times wz times wz. Next, use the commutative property of multiplication to rearrange the terms. So we have w times w times w times z times z times z. Then use the associative property of multiplication to group the like terms. Make sure that there are still 3 w's and 3 z's. Now use the product of powers property to add the exponents. We have the base w with exponents 1, 1, and 1. And we have the base z with exponents 1, 1, and 1. When we add the exponents, we get w cubed times z cubed. So, the simplified expression is w cubed times z cubed. A gigabyte of computer storage space is 2 to the 30th bytes. The total storage space of a computer is 32 gigabytes. How many bytes of total storage space does the computer have? We can use a model to solve the problem. The total number of bytes equals the number of bytes in a gigabyte times the number of gigabytes of total storage space. Let's look in the problem to find some of this information. A gigabyte is 2 to the 30th bytes. Also, the total storage space of a computer is 32 gigabytes. Now let's substitute this information into the model. The number of bytes in a gigabyte is 2 to the 30th. And the number of gigabytes of total storage space is 32 gigabytes. To multiply these terms, we want to write 32 as a power with a base of 2. Let's see if we can do this by looking at the factors of 32. 32 is equal to 16 times 2. 16 is 4 times 4. So 32 is 4 times 4 times 2. Remember that 4 is equal to 2 squared. So 32 is 2 squared times 2 squared times 2. Using the product of powers property, we keep the base 2 and add the exponents. 2 plus 2 plus 1 is 5. So 32 equals 2 to the 5th. Now we can substitute 2 to the 5th for 32. We have 2 to the 30th times 2 to the 5th. Now we can use the product of powers property. Keep the base 2 and add the exponents 30 and 5. The sum of the exponents is 35. So, the computer has 2 to the 35th bytes of total storage space.